Hi guys, greetings of the day. Welcome to my YouTube channel for learning a subject called Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per video syllabus. If you haven't subscribed to my YouTube channel yet, kindly subscribe. Also click on bell icon to receive latest lectures as and when it is uploaded in my YouTube channel. Now, let's start the session number 45, which is based on the different concepts that is called as technical realization of OR function using a shuttle valve. The shuttle valve, which we have already discussed in one of the previous videos, that is with respect to module 4, is frequently termed as pneumatic OR gate because it has the basic logic function of OR. If valve 1 is true, for one or the other inlets, example high pressure, then is also true for outlet C. The equation C is equal to A into B, that is, we are going to read it as C is equal to A or B, and based on that, we are going to understand more clearly with the truth table. The value table is also called as a truth table for OR function, which you can observe here. Now, as I told you, the positions A, B, and C, if position A or B is 0, then C will be usually 0. In the same fashion, if either A or B, or even A and B both are 1, or A is 1, or even B is 1, the C will be 1. This is the meaning of this one. In pneumatic terms, with particular reference to the shuttle valve, this means that at output 2, one signal valve is true when a one signal valve, that is high pressure, is also true at input 12 or 14, which you can see in the figure B. In case of both signal, the higher pressure will dominate. That is the meaning of OR function. To understand more clearly and precisely, OR function can be generated by using two or more two-way, two-position pilot line, spring return direction control valve connected in parallel as shown in the figure A. A, B and C are the three valves, and any of the three pickups an air pilot signal will produce an output D, which you can observe from the figure. Or logic function can also be generated using one two-way, two-position pilot line spring return direction control valve in conjunction with two shuttle valve as shown in the figure B. In this case, the signal applied at A or B or C will produce an output from P to S. This is how it is going to work. This is nothing but the realization of the OR functioning using the shuttle valve. In the same fashion, we will also discuss the technical realization of AND function. There are basically a different possibilities of realizing AND functions in pneumatics. We will discuss each one of them one by one. The first function, AND function through tandem connections of three 2 by 2 direction control valves. It consists of two or more two-way two-position pilot line spring return direction control valves which are connected in series, which you can observe from the figure. If the pilot lines, which are control signals, exist in all three valves A, B and C, then the output D, if a signals in any one is removed, the output will disappear. And what are the advantages here? Least amount of equipment necessary, thereby fewer possible sources of error and economical solution. Coming to one more type of AND function using three 3 by 2 DC walls. Let us understand upon the construction part. The walls V1, V2 and V3 are connected as shown in the circuit which you can observe. V1 and V2 are not connected in any manner, but the output V3 depends on both V1 and V2 together, which you have to observe. And how does it function? Well, wall V1 is actuated by depressing the knob position of the wall changes from normal position to actuated position, resulting in ports P and A connected and are closed. Signals will flow from wall V1 and actuate the wall V3. This results in connection of ports P and A and closing of port R of wall V3. Since V2 is not actuated, there is no output. Similarly, when only wall V2 is actuated, V2 is connected to V3, but V3 is not connected or actuated in the same normal positions, hence no output from valve V3. When both V1 and V2 are actuated, signal from the valve V1 actuates valve V3 and signal will pass from V2 to V3 and hence there will be output. Then coming to the third condition, and function using 3 by 2 direction control valve and a twin pressure valve. And function can also be generated using 3 by 2 direction control valve and a twin pressure valve. The corresponding circuit diagram is as shown in the figure in the slide on the right hand side. Actuation of A and B direction control valves allows output through twin pressure valve. Deactivation of any one of them or both will stop the output of twin pressure valve. Then coming to another technique that is called as using only twin pressure valves. If there are n signals, if all signals are high, then the output will occur. This can be achieved using n minus 1 numbers of twin pressure valves, and the figure shows the two configurations for signals. An operation may be initiated only if all five signals, that is E1, E2, E3, E4 and E5 are present. If any one of these signals are absent, there will not be any output or action is not initiated. This is how the AND function will work on different conditions. Next, we will discuss one more function that is called as NOT function. The NOT functions consists of a single input and a single output. If the output is to be initiated, then there should not be any signal at the input control. That is, the value required which converts zero signal at the input to a one signal at the output, which you can see it from the truth table. When A is 0, C should be 1. When A is 1, C should be 0. That is called as NOT function. If the signal 1 is true for input A, then the signal value Z is true for output C. That is, the equation could be written as C is equal to A, that is, reading as C as A minus naught. A NOT function in pneumatics can be obtained by using 3 by 2 normally open position direction control valve. That is, when there is no signal at A, there will be an output at A, that is 2 of the valve. When the signal exists, the the valve brought to closed position, thereby the port P is closed, blocking the passage and connecting the port A2 and R3. Thus, no output takes place when there is signal at A. When signal at A is removed, The valve is actuated to the normal open position by the spring and the output signal occurs at 2, and the figure shows the working of knot function in a pneumatic valve. That is what we have discussed now. Knot function can also be generated using two-way position pilot line spring return direction control valves, which you can see on the right hand side of the figure. There will be no output when the valve receives signal, and there will be an output when the valve does not receive any signal. Similarly, when the valve V2 is actuated, V2 is not connected to V3, but V3 is not actuated and is in the normal position, and hence no output from valve V3. When both V1 and V2 are actuated, signal from valve V1 actuates and V3, and the signal will pass from V2 to V3, and hence there will be output. So this is about the NOT function. So for this, I would like to stop the session. Thanks for your patience listening to the session. If you have any sort of doubts, feel free to use the comment section for further discussion. I will answer all your questions related to the topics covered in the sessions. Don't forget to like, share, and subscribe. Have a great day. Signing off, Vijay Tavandan.